Then you'll find out it's in New Zealand or something like that.
Right.
Well, that sounds like a great job for the internet to figure out.
Mm-hmm. It almost looks like the back side with Mammoth, and that way the shares from that side.
Yeah, that's what I was thinking it might be. But
Having hiked in this area, I swear I've seen that peak maybe 1,000 times at 1,000 different places.
Yeah.
Yeah, that's
We
one of
keep
those
everybody on their
inaccurate
toes.
memories. Okay.
Appreciate all the early arrivers. Still waiting for Anthony, and oh, there he is. And also looking for Carlos from the city to talk about their upcoming water plan. So we'll give him a little bit of time before he gets here, but we'll slowly move into get the live stream going. Now we'll get the voice of the Zoom god.
The Zoom god.
Ah.
Ken.
Oh, we're already getting people watching it online. That's good. So you can say hi to the two viewers that are watching out there. Unless it's one of you guys that started. Sorry, you want to share the live link if people want to share it?
Yeah.
Hey there, Aaron. So throughout the discussion tonight, Soraya will be dropping links into the chat on what we're talking about. There's also going to be a link to the slides that I'm sharing right now, because we put hyperlinks in all these things. And that way you can go in there and click on what I'm talking about. So one of the things right now that I want to encourage people to do once we get those slides up there is find us on LinkedIn and follow us. Woke up this morning, looked at it, and we're right on the cusp of 1,000, having 1,000 followers on it, which everyone knows what 1,000 followers means. It means one more digit in the space there. Beyond that, who knows? All right. So welcome everyone to the CleanTech Meetup. Today we're focusing on water. I'm Thomas Hall, Executive Director of CleanStart. First, I want to start by thanking our sponsors, Sac State, SMUD, Weintraub Tobin, and Bloomtech Valley support our CleanTech Meetups. Additionally, through Sac State, you can connect with resources if you have a startup through Dean Jawa, Dean Shafizada, and Cameron Law, Executive Director of the Carlson Center for Innovation and Entrepreneurship. I also want to give a big shout out to many of you who are here tonight, who are repeated donors at these CleanTech Meetups. If you like what you were doing, support us through PayPal or the donation tickets that you can purchase on this, or you can also become a regular subscriber. The ones that are there in bold are regular subscribers or people that have donated at all the CleanTech Meetups recently. So today we're talking about water. And when we decided this meetup, I really was like, okay, where are we going to look? And one thing that someone threw to me is that the city of Sacramento, its utility is making its water plan right now. In fact, they had I believe, a meeting on it earlier this month. So right now I'm going to highlight Carlos, who I believe is in the audience from the city of Sacramento, to tell us what is going on with the city of Sacramento, or what they're working on.
Yeah, absolutely. Thank you, Thomas. Hi, everyone. My name is Carlos Eliason. I'm a media and communications specialist with the City of Sacramento Department of Utilities. And Thomas is right. We're actually in the process of making our a plan to basically manage urban water supplies. It's accordingly called the Urban Water Management Plan. That was actually supposed to go to a meeting, a public hearing during Sacramento City Council a week or two ago, but it got postponed. We had some other items. So that one, I believe, is actually on June 29th. Any of you can join if you want to make your comments heard. We encourage public participation. I guess the first thing, I mean, was that okay for you, Thomas, or do you want me to?
That was great. But I want to have a quick question and hope that you can stay around for some discussion on it. But what are, the top kind of 3 things that the water utility looks at or is considering in the plan?
Yeah, so what we actually provide, obviously, is drinking water. We also provide wastewater, stormwater, and water conservation services. So what the Urban Water Management Plan does is it's a plan that's updated basically every 5 years. It projects our water efficiency goals, water usage, water supplies into the next several decades. And it does that to be able to deal with situations like we're in right now during these very dry conditions.
Excellent. So if you want to get input on that, Soraya and I both put links in there. Check it out and put your input in so you can say what's important to you and give feedback. If a lot of us remember when SMUD was coming up with their zero emissions plan, they went to the community and asked for input. This is the same thing, but with our water. So make sure you go in there and give them feedback.
Absolutely. We welcome it all and hope to see you all there.
All right, excellent. Are you going to be able to stick around maybe for questions at the end of the presentations, or is that a bit late for you?
Yeah, I'm gonna stick around as much as I can. May get a couple calls in between, but I will try and be here if I cannot. I'm happy to answer questions over email. You can email pio@cityofsacramento.org, and I'll try and answer those there.
Excellent. I want to encourage everyone to make sure that they check out a lot of the resources for the clean tech ecosystem in Sacramento. Right now, there's some upcoming opportunities for startups and nonprofits that focus on the Sacramento area. CalSeed is going to be coming up soon. We actually have, I think, some CalSeed winners here speaking tonight. Valley Ventures from Blue Tech Valley and the Wet Center. That is an accelerator that has been very successful in moving companies along. And I want to actually call on Hella Peterson to give us a quick update on that.
Sure. Good evening. I'm Helle Peterson, and I manage the Water, Energy, and Technology Center at Fresno State. And that's also where the Blue Tech Valley Innovation Cluster is headquartered. The center has been around since 2007 and have worked with supporting water, energy, and ag tech startups ever since. In 2015, we got funded by the California Energy Commission to be one of 4 regional clusters in California to support commercialization of clean energy technologies. And we cover, Blue Tech Valley covers the whole Central California, down to Bakersfield, up to Oregon, and parts of the Central and Northern coast. And also Sacramento is in our area as well. And that's why we have now for the last 5 years and will continue for at least the next 5 years to work with Thomas and Gary and their team at CleanStart to support companies and entrepreneurs and innovators in the larger Sacramento region to support them with moving their technology forward. As Thomas mentioned, we have different programs that we can offer. We have Valley Ventures, which is our accelerator, and I know that's going to be a conversation about that next week, so I won't dive too much into that, but if anyone is interested, I'll highly encourage to pay attention to that. But we can also help earlier stage company, technology evaluations, conversation plans, and a lot of resources like that we have available other than what we provide to our partners.
Excellent. Thank you very much. And all right, so we're still going to get into tonight's presentation. So tonight we're talking about water. We're going to be hearing from companies that make a difference in water. Water is a critical part of our infrastructure. It's a very scarce resource. We literally need it to survive. In California, we have faced repeated droughts that have severely impacted agriculture, resulted in fires, has impacted cities, and even more. But entrepreneurship, we like to think that problems are things that we can just apply, that we can apply solutions to, that it's an opportunity for us to go in there and make a real difference in people's lives. And I don't want to think anyone to think that, that's trivial. But tonight we're going to be hearing from startups that have found solutions to different problems in the water space. And we're going to have a conversation about how they have made an impact. So I'd like to please welcome Anthony Jones, CEO of Waterhound Futures, Chris Peacock, founder and CEO of AQUAOSO, and Chuck Hansen, founder and chairman of Electroscan. And we're going to start off with Anthony Jones, who is the CEO of Waterhound Futures. He has extensive experience in management and has put together and led teams to discover innovative technical solutions designed around seawater desalination, reduced energy use, and minimize carbon footprints. So please welcome Anthony Jones. I'm going to stop sharing so you can share if you have slides.
Great. Is that working? Okay, perfect.
You're a little quiet. If you can put your microphone towards your mouth.
Oh, maybe I should put it down. Is that better?
Perfect.
Got to come dressed for these things. Hey, my name's Tony Jones, and I'm the Chief Executive Officer for a company called Waterhound Futures, and we transform data into action. We are a startup, but we are relying on about 20 years of historical work that has been done to design and build wastewater treatment plants for Fortune 500 companies. My other partner, Michael Levy, is that person who's been doing that work, and in the last 20 years, he's been building a database, a data set, and algorithms for several hundred different treatment processes and several hundred, like 800 different contaminants. So that's what we're interested in working with people in the Central Valley. We did win a California Energy Commission CalSeed award, and so that's what we're using the money for, is to solicit input from 3 different vendor or wastewater treatment plants in the Central Valley. Most of you have probably seen or heard about flight simulation and or seen the flight simulator that's on some people's computers. We're doing a very similar thing for the wastewater treatment sector. We're building a virtual replica or a digital twin of the operating system so that people can go and quote fly it into different scenarios and see how it operates. And we know that there's a couple dozen wastewater treatment plants around the world here. At least in the US, there's almost, I think there's close to 10,000, or there's more than that. There's several thousand or tens of thousands of treatment plants. Right now, we're just focused on the Central Valley because of the mandate from the Energy Commission. I've got some other people working with me. I've got 2 other co-founders, Julie King, who's in London, and then Michael Levy, who's in Aberdeen, Scotland. We're fortunate to have extended the team through consultants, and one of them is this person named Simon Wetzel, and he is actually he's a mathematician and has worked for the government of Sweden looking at cryptographic analysis, and has done 2 startups that were purchased in the fintech side. So he's acutely aware of the need for security and privacy of the data as we move forward. We're also a member of the UK DIT, Department of International Trade. They have a program for entrepreneurs, and Julie is a representative on that, and one of their key people working on developing this company in the UK market, and also through the Commonwealth. So that's how we roll things out here. We have some advisors that are giving us some interesting advice and really knowledgeable advice. Jacob is with the Water Retail Company, which is a group that is able to wheel water in the retail market between different vendors, and has been quite successful at doing that. Stuart Orr is with WWF International, and Chital Walsh is an entrepreneur up in Canada. We have process engineers out of the Philippines. We have software developers out of Poland, and we're using a group out of San Francisco called Open Space to do 360-degree camera remote walkthroughs. This came up during the pandemic where we wouldn't have access to some of the plants, so we're able to send them a camera mounted on a hard hat, and they basically walk through the facility, and then we basically digitally stitch it with our partner to have a flyby, so the engineers can look at the drawings, which may be 3 to 5 years old, and make sure that the drawings are what's there match, and it's what the operator is seeing. So obviously you can't improve what you don't measure. That's pretty basic, and so we're interested in the data that people have for the influent water that's going into the waste side of their business, not only agencies, but also in the industrial sector. Some of these we've identified through the regulatory compliance. The State Water Board has a list of people that can't meet the Clean Water Act. And we're interested in basically taking these digital models and running optimization to let them know, or to inform them on how they can operate their system more efficiently. In the US, about 3% of electricity across the country is used for moving wastewater around. So we believe there's a good part of that could be optimized and significantly reduced. Our main goal is to prevent pollution or contamination of freshwater resources, which are valuable and will become more valuable, as we know here in the state of California. My time is pretty quick here. So anyway, we're in the development stage. We're pretty ready for a commercial product. We have a beta out there that's being tested, and then we'll be adding some functionalities through the next 2 quarters. As I said, in the front end of this is not blue sky technology. This has been vetted by some of these Fortune 500 companies through the offline model. So we've basically converted that into an online model with a cloud database behind it to run the calculations in milliseconds. The market is resistant to change. That's mainly a function of the demographics. The wastewater treatment operators tend to skew towards retirement, and so they're very conservative, and it's a bit of a push to enter that marketplace. Another part is that water and wastewater are digital laggards in the general sense of the word, because of just historically they've been slow to react. There's public health issues that are, of course, concerns. And the final thing is that they're pretty energy intensive, and we believe that between 20 and 45% of the operating costs are accounted for by just the energy consumption. The global market's big. It's in the B's, and on top of that, about 50% of the wastewater goes untreated globally. So from that perspective, the market is several trillions of dollars. We've got a plan to continue some programming here, and the only other thing I was going to leave you with is that there's a big market for opportunity for reuse. So I think I'll leave it there. Thanks.
Thank you very much. We very much appreciate it. If anyone has any questions, feel free to put them into the chat.
Yeah, we've got one in there now. Tony, are any of the demonstration sites in the Central Valley or in California that you mentioned?
Not yet. We're talking with several food manufacturers and beverage groups, and also a state agency about doing the demonstrations this summer with them. So we're going back and forth. We have not identified the spots yet, but we're looking outside of Sacramento and also outside of Fresno.
Cool.
Oh, excellent. Thank you for that. Next, I would like to welcome Chris Peacock. Christopher is currently the CEO and founder of AQUAOSO, a software platform that reduces financial risk for the agriculture economy by providing data, insights, and climate analysis. AQUAOSO is an alum of Techstars Sustainability Accelerator, as well as the Valley Ventures Accelerator that we talked about earlier. So if you have questions about that, you could always ask him how it was for him. Christopher also has published a book and spoke, I believe, at our second CleanTech Meetup that we had back in 2018. So we're thrilled to welcome him back right now. And I'm going to spotlight him, and he can go ahead and start. And you can go ahead and start sharing your slides.
Awesome, thank you. 2018 seems like forever ago. Let's see. Let me get my slides up. All right, hopefully we good. Can you see? Thumbs up.
Yep.
All right. Awesome. If I sound a little out of breath, I apologize. I went on a little bike ride earlier today. We're up in Lake Tahoe, and the altitude is very different than what I'm accustomed to. So thanks for having me, though. I'm really excited to be here. It's great to share a virtual stage with some really great folks doing awesome work. I'm going to take a little different approach than usual, though, for today's discussion. Rather than really delving into the awesome water security platform, which is like a credit score for water that AQUAOSO has built, and beat our drum to share why water risk is truly business risk, or talk about our business model, I want to share with you the concept of data acclimation and a few lessons that we've learned over the last few years that have helped us build a data acclimation maturity model, which I think could be really interesting to a lot of folks here as you think about your business and your customer's business. But before I do that, I want to start with a basic premise. First, we live in a world where our climate has already changed, and it's continuing to change. Right? Environmentally, our climate continues to shift and change in both predictable and unpredictable ways. Think about extreme weather events such as hurricanes, droughts, floods, and wildfires. If you live in California, you're very familiar with many of these. Politically, our system and our climate has definitely changed over the last year. Right? The current administration is pushing broader and stronger climate and ESG reporting and management requirements. And then, of course, globally, we have the Paris Accord and the UN sustainability goals. And socially, climate has shifted as well, right? People are expecting greater transparency with the businesses that they buy from. Millennials expect that corporations will be doing good. And the shift to working remotely is forcing us to really rethink how we manage what has historically been centralized information. And then, of course, the digital business is certainly changing as well and continues to evolve, right? DeFi or decentralized finance is no longer a sideshow at the carnival. It's really challenging the traditional banking industry. Bitcoin hit an all-time highs, and of course, it's all over the place. But major industries continue to digitize their operations. And whether you can believe it or not, like, we're actually tracking carbon sequestration on the blockchain. So yeah, climate, however you want to define it, really is rapidly changing. And the questions that are really on everyone's mind, at least the folks that we talk to, and maybe even on yours, is what are we going to do? How do we track this stuff? Well, how are the new regulations going to play out? What does it look like? And how does this impact me and my business? So as you already know, my name is Chris Peacock. I'm the CEO and founder of AQUAOSO. I've been working at the center of water and data for the last 20 years. AQUAOSO is on a mission to build a water resilient future, and we help organizations understand water risk in their portfolios through a SaaS-based business model. Just a little bit of background, we operate across 8 Western states, and we're continuing to expand. Our customers include more than 30 national banks, international food brands, and farmland investors. We've got 15 full-time employees. We did participate in the Blue Tech Valley Ventures Accelerator program, which is where we actually pivoted our company from doing water markets to water risk analytics. And we're a Techstars company. We recently closed a $2 million Series C round. So for all intents and purposes, we're still a fairly young startup in the overall scheme of things. Over the last few years, though, as we've been solving the problems of water risk, we had to develop a purpose-built data acclimation platform that could ingest both macro water models, local water availability, crop water budgets, and a ton of other information, and put them in the context of both new loans and existing portfolios of loans. So for reference, data acclimation is the process of geospatially contextualizing data across a company and with climate-related data, or simply put, using location and map-based data analytics to understand the impact of climate risks on your business. So as AQUAOSO built our data acclimation platform and started ingesting various data models, we very quickly learned like our first few lessons. The first is that macro data models are great, but they need to be ground truthed. And small data, while not as sexy as big data, is really critical to analytics that matter. The problem is that small data is really hard. It's fragmented, it's messy, it ultimately needs to be normalized, standardized, and geospatially mapped in the context of our customers' data, which is loan information, property owners, operational data, which really led us to the second lesson, which is that the data models need to be integrated with customer data in a geospatial platform in order to really be understood. Unfortunately, most off-the-shelf GIS tools, they're not built for robust analytics and integrations. You can piece systems together and you can spend millions of dollars around integrating software. But what we found was that by collaboratively developing a purpose-built data acclimation platform with our customers allowed us to better understand all of the data. And if you're integrating data sets, especially with banks, the lesson here is that we need to understand how a data acclimation platform actually fits into a broader digital strategy. So if you look at other organizations like BlackRock, who are really pushing the envelope and leveraging the digital tools that are available to them, you start to find that these themes are repeating. The Troubled Water report that they published not too long ago used advanced geospatial data with macro data and micro data sets in a digital framework to really understand the risk associated with real estate investment trusts. So in order to take advantage of any sort of climate analytics, whether it's ours or yours or somebody else's, and start to report on ESG to shareholders or the board or regulators, we really need to define a digital path to follow. So this is like one of those really big lessons learned at AQUAOSO. As we were building killer water analytics, we were actually having a hard time deploying them to some of our early customers because they didn't actually have a geospatial platform or an integration layer of their own data for us to be working with. So we had to build that integration layer as part of our broader data acclimation platform to answer the question around water risk in portfolios. So as we've been evolving as a company with our customers' input, we started building a data acclimation maturity model to help inform our customers' journey. And I think similar models like these could really help inform not just our journey and our customers' journey, but maybe your journey and your customers' journey as well. Maturity models are a really great way to surface value propositions of a project or product at various stages. So just briefly, we'll walk you through our very new, very young, very imperfect maturity model that seems to be getting a lot of attention from our customers and helping them understand what steps they could take or where they're at in the overall scheme of leveraging their data or our data. So the first stage, this is the most basic. I'd like to think that our customers are beyond this, but in reality, most are not, right? This is paper and Excel is still very much used in their operations. And in some cases, especially around water data is existing on onion paper, like literally thin, translucent pieces of paper that are degrading over time, definitely not digitized. So a lot of companies are kind of sitting in the space and trying to figure out like what to go do next. Stage two is when you start getting into the more formal systems of record. This is where data is getting organized in systems like Salesforce, HubSpot, Oracle, MailChimp, and maybe even like a broader digital strategy starts to come into play to integrate other data sets together. In stage three, data set starts to get geospatially mapped, right? This is when you realize that your data is hard to contextualize in just a database or on a pie chart. So moving beyond ports on a map to fusing and visualizing all of the data that is related to customers. So at this point, you're probably thinking about Google Maps, Esri, building something in-house, or talking to a professional services firm to build a custom project. Stage 4 of this is about analytics. This is where things really start to get interesting, and the digitization of data and water really starts to come to fruition, right? Maybe you're concerned about environmental risks, or you want to see data in the context of third-party data sets, or your shareholders, your board members, or regulators are asking various questions about environmental questions on the operation. And we're seeing this more and more, right, with the new regulations and the new administration in place. So at this stage, you probably have some sort of Esri product in place or custom-built GIS system, and you're starting to look for other data sets that you can use and figure out where the resources are going to come from to integrate and maintain the complexity of a system. And then finally, stage 5, this is where you start moving into actionable predictive models, right? Answering the early questions of what do we actually do? Here you can visually map your data, you can contextualize it with climate data, and you can have a suite of analytics and predictive models that you can use to create mitigation and adaptation strategies for you and your customers. So most people are at various stages of maturity models, especially across different systems and different departments. At least at AQUAOSO, we've learned that by walking our customers through defined models like this, we can better affect change and meet our customers where they are today while providing them with a roadmap to really future-proof their business. So as you think about your own business or your customers, maybe think about the lessons that you've been learning along the way and how those can be applied to a maturity model to better map your journey into a future state. So with that, thank you for letting me share some lessons learned as we've been building AQUAOSO. And if you have any questions or want to continue the conversation outside of this venue, please feel free to reach out to me directly.
All right, thank you very much, Chris. That was actually really informative, and I think it's going to lead to a great discussion later. Next, I would like to welcome Chuck Hansen, founder and chairman of Electroscan. In 2011, Chuck founded Electroscan to provide governance and stewardship for the water tightness and testing and certification of water and sewer pipes. I'm definitely excited to hear more about it. The first startup competition that I went to in Sacramento while working at CleanStart featured Electroscan, and they had a whole bunch of people around their booth looking at leak detection. So I'm going to spotlight Chuck here and let him take it away. Got your video. Did we lose Chuck?
Let's see if we can.
Oh,
there he is.
Just hold on. Can you see that?
Yep.
We can. Do you want to start your video so I can spotlight you?
Yeah, hold on. Here we go. There. There we go. How's that?
Excellent.
You see that? Hello, CleanStart.
Good.
I think I remember that that venue. Wasn't that up at Sierra Nevada?
Yeah.
I thought there was a free 6-pack of beer or something if you went there. Hey, I've been at this a long time. So, I started back in the 80s. It was great to see all of the activity happening in Sacramento. You can kind of see the years I've been in the water business. It's been a lot of fun over those years. But I got to tell you, I simply cannot believe what we're kind of living through right now. You see on the left what we looked like a year ago with the drought monitor. And, we are now at the worst levels in the history of the 21 years that drought monitor has been around. So it's been a real interesting area. And it's not just California, we're expanding this all over the West. So leak detection and finding leaks and quantifying those things, I think is a pretty big deal. Hold on, let me see if I, there we go. What we've been doing is we have been testing. I kind of started this as a vacation company because I had Hansen for such a long time. And so we were doing a lot of projects over the world, and things really started getting hot last November. We won the UK Water Dragons event for our water leak detection. I'm going to tell you a little bit more about that. We had a very great award at the start of this year, and just this last week, kind of a top product award from Environment and Energy. So we do leak detection, but we're more than that. We are a platform-based company. So we're looking at doing condition assessment, things like pipe wall thickness. We're also looking at line locations so that we can put sensors in probes inside the pipe. And we're also now looking at water quality. So many times we've been through COVID, so many people find out that we've got something at the treatment plant. We are looking at using a mobile platform because we've now figured out how to get into and out of both water and sewer pipes. So with water, we're really supporting two products. We've got our Delta. This is a 3,000-foot cable, 1 kilometer. And then our Trident, which is a 400, fixes on top of meters, hydrants, and so on. And we now have figured out ways to put our probes into fully pressurized pipe without any service interruption to find leaks. This is how we used to find leaks. We listened for them. And in some cases, we'd actually have either a sniffer dog, as you're hearing about in some cases, or we'd put a helium tracer in there. But 9 times out of 10, acoustic was the way to go. And in fact, a large city has used acoustic data loggers quite a bit. Here's a 65-mile survey that was done. Look at this. Of 165 miles, 10 leaks were found. 7 on the distribution side, 3 on the customer side. 1 non-mile section here on Belt, only 1 customer leak was found with acoustic. And take a look at the inflow and consumption and the total water loss. And if that same water loss was throughout the entire city with all of the service connections, we'd be looking at 5 billion gallons of water loss. And 14% that we're looking at here is kind of a nice total. That's about 400,000 swimming pools worth of stuff. So why has acoustic been so hard to find leaks? The number one reason has been household water use. If you're out there trying to use an acoustic, you'll get a water hammer, you have people turning on and off waters. That's why so many of these things are done late at night. High groundwater, if you're close to a water source, a lake, river, stream, ocean, you're looking for that differential. And if you've got water on the other side of the pipe, it's just going to be a natural insulator. Pipe material. There's a reason why tuning forks are not made of plastic. If you've got a plastic pipe, very difficult to hear a leak in it. Couplings, repairs, those will interfere with listening to a leak. Different flow patterns. How about street noises? Take a look at the leaf blower. That's the number one way of not hearing a leak on a pipe. Trenching, bedding materials. If I've got a leak and I'm holding it right back there again, that's another way to hold that water. I'm never going to hear the leak if that's the case. If I've got air bubbles, air pockets, just the judgment. You can see the guy that is taking the test at the hydrant, listening for 30 seconds and moving on. That's our number one way of listening for a leak is on a hydrant. And of course, acoustics can't hear. I like what Tony just said. You can't improve what you don't measure. Not one tool on the market measures leaks in gallons per minute. How can you possibly fix that? And then there's pressure. You know, when you're testing some of these things, you want the pressure as high as possible. So honestly, if you don't have a leak, you're going to make one. But if you've got lower pressure, take a look, you can hardly see that difference. So electroscan, we do away with all of that. No noise impact, no flow, no pressure. This technology measures the size of holes. That's what we do. We don't push water through it. We measure the size of the orifice, giving the PSI. I'm going to tell you the gallon per minute, the holy grail of this. And I'm going to have focus. So I'm going to have 1 centimeter accuracy in the location of those leaks. How do we do this in real life? We're just getting finished with major projects at Angling, Severn Trent, Thames Water. So when we roll up, we already know what kind of fitting we've got. We'll have an insertion tube, fully pressurized. We'll have a chlorination chamber. So anything that goes in, we know that that's hermetically sealed. So as we go then, this is not Aquam, this is not JD7. We'll have a hydro chute and propel up to 1 kilometer into the pipe. This is a combination of acoustic, just so I can show you what you can't hear, CCTV, and electroscan. As I make it 3,000 feet away, I'm going to close that chute. And on the pullback, this is where the magic happens. I'm going to take a low voltage, high frequency electric current, and I'm going to interrogate the pipe 360. And if I find any opening, I'm going to measure the size. And I'm going to tell you exactly how many gallons per minute that leak is, or in the British case, liters per second. If you understand this picture, you get what electroscan is all about and the science behind it. I've got 2 ends, and I'm using water as a conductor, and I'm going to evaluate every opening inside of a pipe. And I'm going to do it with 6 AA batteries in most cases, 40 milliamps. All we do is we set up an electric charge inside the pipe, a grounding stake. And again, if it's a perfect pipe, I have a flat line. If I have a leak at a joint, at a crack, then I will go back and return and actually measure the amount of current. This is what our COMSOL models look like. So I am actually measuring the size of that opening as I'm having that probe go down. What does that do? Well, the one thing it does is we have the ability to test the water tightness of every joint in a pipe. Where Sahara or Smart Bulb may have, if they're lucky, 1 leak per kilometer, our average is about 100. And we will assess every joint to see if electric current can go up, turn left, and hit ground. Every crack, this is key. If I got distributed cracks, if I've got concentrated cracks, this is how I'm going to come out and do rehab based on where that is. And with TV, we can see any of the illegal connections, which there are about 5 to 10% illegal connections out there. So here's a case study, a little 560-foot pipe, 24-inch diameter, failed multiple hydrostatic tests, failed multiple acoustic hydrophone tests, data loggers, correlators, helium tracers, pressures were erratic, flow, turbulent, traffic, noisy. Our crew shows up. 2 hours later, we go up to the cloud. Just showing off. We have clouds that go ahead, transmits that data up less than 10 minutes. So I don't care if I'm in the desert of Abu Dhabi or on the Ginza in Tokyo, the data is displayed automatically. This pipe, 15 leaks in 600 feet. You can see 2 major. Every leak is specifically identified. And because I got TV, now I know where to look. But this time, when I see an angular rock at a joint and it hooks up to a spike, I know exactly that I've got a leak right where they went ahead and installed this pipe. And we have acoustic, and look, it's the British, so we have a bake-off. Every time the acoustic hit the wall of the pipe, every time it went through, we had a false positive, so that couldn't help us. So we're now in a world of who does GPM and who doesn't. That's what we do. We've got our Delta, we've got our Trident, and we have new things coming out, which we like to call Kingfisher and Swordfish. These are small plumbing so that we can go into 50 millimeters, so that's 2 inches, or down to 1 inch. We've just opened up a training facility because we now sell our Tridents out here. It's right, if you know where Leatherby's ice cream shop is, we're right down the street. We do full our training. All of our guys can show you how to turn these things into 90s. And we hope you come out and see what we do. This is changing materially how we find, quantify before and after leaks. And with that, I thank you very much.
right, so first of all, round of applause for all three presenters. Those were all terrific. We'll begin a little discussion here and pick up as many questions in the chat or turn to the people who are watching to see what they want to talk about there. But so Chuck, I mean, really what you're talking about is there's a tremendous amount of loss. Water is such a valuable commodity, and obviously it's getting more scarce. And potentially 14% of what's going through the pipes is just leaking out. So you've got a huge potential. Why did everything seem to start in the UK versus in the US that has, lots and lots and lots of leaky systems, I would say? Is it just because of where the people were, or was there some institutional reason why people were more open to look at this technology?
I got to tell you, the UK is, so we've got 10 major water companies. I've been going to the UK. In fact, when we had our big earthquake, Loma Prieta, I was actually in London where I was meeting with WRC. That was 1989. I wrote the first standard for TV inspection for Houston. And, when Maggie Thatcher started all of the water companies and had them go private, you've got 10 big water companies of England and Wales.
Yeah.
Right now you're down to one public company. You've got a ton. Their smallest water company, I think, is around 30,000 miles of pipe. So it's real convenient. We did a couple of tests down in New Zealand, and really the guys from the UK heard about it first. So I like to travel a lot, and so we went over there. Had a department there for a couple of years, and we just got to know those guys, and they were prototyping a lot, and we just wanted to figure out a way how to get into British fixtures first, and now kind of circling back and taking care of the US.
Interesting. So, still most of your business then is overseas. It's not US based. You're coming back to the US, but historically it's been overseas.
Well, I got tricked in it because I'm a recording artist. I'm in my studio here, so I play the saxophone, and all of that came crushing down when Ken Carey called me up and said, "Look, is there a way to test lined pipes?" I said, "Well, lined pipes, what is that? Why do you just what does the TV show you?" He says, "Well, when you TV a lined pipe, you can't tell if it's watertight or not." And so I had heard about this German technology that was using electric current, and so Ken Carey kind of poor boyed me into the sewer business, and I never owned a TV truck, so we bought a couple, and we started doing things in the sewer business over here. But then, of course, we quickly went over to the UK with those as well. So so it really is kind of been growing now exponentially these last couple of years for us.
So you're hiring people, you're going different places. You must be profitable by now.
Well, we're entirely self-funded.
Right.
And, if I look for a round, it may be a $20 million round a year from now. As we're looking for equipment, we're looking to license contractors so that they can use our equipment to do that. We're of course paid every foot that we scan. So our cloud is, all of the action happens in the cloud. So that's quite profitable. What we're seeing now is, one of your viewers is actually a CEO from an Indian water company. I'm just starting the Indian electroscan company in the next couple of weeks. And they've got such tremendous water loss over there. A lot of plastic pipe, some of the traditional acoustic things can't work over there. So I'm just having fun, and really it's a target-rich opportunity. I was on the phone with some folks from a city in Ohio. Their water loss in some cases were 70%. So it's not just some of the developing countries having major water losses. It's right home here in the US.
I think there's ripe territory for you.
Oh yeah.
It's like one of the other speakers said, if you aren't detecting it, if you aren't measuring it, you don't know what's going on. So, we're in the middle of a extremely serious drought here. And I can't imagine how many millions of gallons of water are just leaking away and nobody even knows it. congratulations on all that you've achieved there. And yeah, since we gave you a 6-pack of beer, you've really taken off. We must have the magic touch.
Yeah, was that called CleanStart back then? And I'd never been up to Sierra Nevada,
Yeah.
Before that time. So I had a lot of fun.
Yeah, well, glad that worked out for you. So turning back to the other presentations from Chris and from Tony. So Tony, can you sort of capsulize what's the biggest gain from what you're trying to do? And you're talking about you're preventing contamination of fresh water. A lot of it's monitoring wastewater facilities. Are we just talking about trying to segregate fresh water from treated water, or what are the big gains that you're going after with Waterhound?
Well, because of the Energy Commission grant, our focus has been on the energy consumption. A lot of first of all, we're targeting some of the industrial players. And so, like, for example, they may be making peaches. Well, wastewater is not exactly their forte. It's not their core expertise. So we believe that they usually put the junior guys on it so they don't screw it up, and then they move them into the production side. So we just think there's a lot of opportunity. And well, we know there's a lot of opportunity for going in and giving them more efficient, more optimized systems. None of these systems are optimized. Most of the people don't even look at the data that they have already. So we have a framework that you can put the data into and get some sort of analysis. So that's kind of, we see this initial setup as being more on the energy side, but eventually we're going to see water reuse as our prime thing that we've been going after.
Hey, Tony, I got a question for you. I hear the water energy nexus. So what's your rule of thumb of the component cost of energy to a typical wastewater treatment plant? I mean, if there is one, how is?
Yeah, I don't have something like that. All I have is, I've got an average on BTUs per year per volume, or per volume per year from some work that was done by the EPA, but I don't really have just a rule of thumb. But it's kind of weird because to most energy you need water. I know for like a barrel of oil, at least Shell has reported they need 40 gallons of water, 40 barrels of water to get that 1 barrel of oil, which just seems like a lot of water to be moving around just to get that 1 barrel. And yet when we treat the water, we also have to put energy into the system. And I don't know if you've looked at your bills, but usually the sewer bill is bigger than your drinking water bill. And there's a reason for that.
This is a hot button issue over the UK. They're right now at AMP7. That's their 7th asset management plan. And they've really put a relationship between the amount of infiltration, so rainwater that comes in through the pipes and then goes down to the treatment plant, and of course the pumps are working overtime. It's overflowing back into the rivers. There's a report almost every week of the few rivers that you can swim in the UK because of these overflows and so on. But it's the Ofwat has just hammered the British water companies for these things, and tied the whole energy output and carbon based on that. So I really thought it was just kind of a nice thing to say up until a couple of years ago. But this has got teeth in it now. So even old dogs like me, I'm 65, and it's really interesting to see how these things are really, coming up to bite some of these larger utilities.
Yeah, one of the things with the utilities is the water, if they put that water out there and there's a 30-40% leak, they don't get any revenue on that. Right. So for them to fix it, then they can actually make some money on it. I know that when I was in Malta and some of these other countries, they're their rates are about 40 to 50%, which is crazy. So yeah, I mean, it's one of the areas. It's kind of like the one of the areas you got to deal with. But do you dig up the thing? Do you go trenchless? Do you put in sleeves? There's a whole bunch of different ways of fixing the things now, but they got to be fixed, and that's a kind of a special expertise.
Agreed.
Okay, Chuck or Gary, is it okay if I ask a question?
Yeah,
Dan
sure.
Cullen here. Hey, Chuck, Dan Cullen, good to see you.
Hey.
Hey, so is there any other competition other than Acoustic for your company as far as other technologies or other companies using a similar type of technique?
Yeah. So if we just look at low voltage conductivity, we were lucky enough. I knew some of the guys in AWWA, so we're part of the M77. There was one other company on the planet that was playing around with conductivity, and that was WRC. And WRC was the company that did Sahara. That was a tethered probe, acoustic probe. They have a smart ball, an untethered probe. But our patents are pretty much pretty different than them and measurement. But there are 100 different methods for trying to find a leak. We've got supposedly satellites to identify it, but again, I was just on the phone with one of the folks in Brazil, and when you've got high groundwater conditions, I mean, finding water on Mars and finding water, in Munich are two different things. And so most of the other technologies are focused on, finding those critical DMAs, those district meeting areas, so we know which ones. I mean, where's the low-hanging fruit? Sacramento, 80% of my water loss is from 20% of my pipes. But where is it? So we work with sensor-based companies. There are great metering technologies in the field to get us to those DMAs. We just happen to play, by the inch and by the foot, because we want to make sure we know where X marks the spot. That's what this game is all about. There's so many dry holes that get done. I mean, if I have a correlator where I've got an acoustic from two spots, I may find a leak in the center someplace, but I'm missing all of these other leaks. And so I can very easily come back and be fixing another leak at the same one and have no flow reduction. So, we're really, it's been a huge game of whack-a-mole for the last 50 years. So, how can we get more precise for that? So, outside of acoustic and satellite, there's pressure transients, helium tracers I mentioned, but again, helium will leak. And again, you want to know, is it at the tap? Is it at the main? We're trying to be more granular and more forensic so we know where these things are. And I got to tell you, there's a lot of great companies out there that are using AI to tell you where to find a leak. But having done 1,000 miles of electroscan, leaks have nothing to do with age. I mean, look at me, I'm 65. You'd never know. Well, maybe. So age is not a factor for what pipes to fix or pipe material. Or I'll tell you, the number one way to know which pipe to fix is the contractor that put it in, because what we're actually seeing is when people are digging up and replacing pipes, when I see a gasket hanging down from a joint, it's been like that since they put it in. So, we've just done $1 trillion. I don't know how much water and sewer is actually going to get of this when it rolls down. But, I'd almost have to say, forget about the leaks that are out there. Just make sure the pipes you put in the ground don't leak. And right now, there is no standard of acceptance for a new pipe that has zero water tightness. Can you imagine that? There is not one standard, not even a new plastic pipe. Is there a zero standard? There's always an allowance for leakage. And the majority of pipes use visual inspection. So we really have to do a much better job on not just knowing which ones to fix, but approving the pipes we put in the ground.
So is that a function of the structure of the industry here, that it's mostly municipal water systems? There's obviously some private systems like American Water Company, and a few others, because it amazes me that, you know, all the conditions are different, all the rules are different when you cross some city border, whereas in England, with the reforms there, going with the Office of Water Regulation, you know, now they have some basically nationwide standards, and somebody overseeing all this. I'm taking from what you're saying, nobody really oversees this stuff unless it's, you know, a city council somewhere that is aware of what's going wrong.
You really got to look. It's in the game. Look who owns. If you remember the old Enron days, you know, when Enron, before they crashed, they bought their own UK water company.
Right.
And when they went bankrupt, a family in Malaysia, you know, bought Wessex Water. And I'm going to tell you the secret for how we sell leak detection in the UK. And that is, we want to find pipes that don't need to be fixed. Technically, all of the private equity firms that now own the British water companies have already allocated CapEx to replace all the pipes. So if you have a solution that will tell them that that pipe does not have to be replaced, again, we're accounting for that asset in perpetuity, right? So if I can say and have something that can be trusted and say, you don't have to fix that, oh my gosh, you just freed up 250 pounds per meter. And that's music to their ears. So they can take that off of CapEx and they can put that someplace else. So deferment of CapEx is probably the #1 reason for using a tool like ours. They can't really tell with Acoustic until they really get into that. So it's all about the dollars that are over there. And so whether you take a look at a investor-owned water company over here, or like we want to do, which is save water, so we're not having to build bigger reservoirs, new dams, new treatment plants, and so on. You know, let's fix what we have. So, and because we're such a fragmented society, I was talking to the Sacramento, to the State Board of Water Resources, 8,000 water providers in the state of California alone.
Right.
So, you know, it's a target-rich opportunity and very fragmented. So, you know, once you find some good customers, you can scale up pretty fast.
Well, let me turn to Chris. That last step on your chart, Chris, you know, where you come up with measures to adapt and survive and improve. What are some examples of where you're going to point people as things they could do to improve? They're, you know, doing a much better job now of understanding their systems with the data, but what are some examples of things they could do to improve?
Yeah, for sure. You know, I appreciate the conversation that Chuck and Tony are having on the municipal side, having spent 15 years of my life working with municipalities and deploying meters to some of the largest water utilities in the US. When I started AQUAOSO, I was like, oh, finally I'm out of the water utility space. And I tackled agriculture, which is like just as crazy and fragmented as insane as any other space with way less regulation. So, you know, when we think about water risk, we're thinking about the quality of water risk. So is it of the right quality for the type of operation? Is obviously enough quantity, which there's definitely not right now, given the drought that's going on. Is it the right price? How much does it cost? Because as we know, like, water is expensive, it's heavy, it's really, really costly to move and energy intensive. And is there enough of it in that particular area? So we look at kind of those 4 elements as we think about water risk. And one of the things we identified early on is it's one thing to help our customers identify, understand, and monitor risk over time. But that last step of taking action, what do I do? How do I make a difference? How do I mitigate the risk in the long run? That's where we're spending a lot of time right now. And so in, like, for example, in California, in the Central Valley, one of the ways farmers can mitigate risk, it's not the most favorite, is fallow the land, rip out the almond trees, right? We're seeing this all over the news right now. Another way is in some cases, you go checkerboard the fallowing of the land, which isn't really great for the environment, because then you don't get like wetland redevelopment or other areas in which you can really restore the ecosystem while you're fallowing the land. So we're starting to give suggestions to our customers kind of at a more macro scale of, by working together, let's go fallow land that actually restores the natural ecosystem. And by doing that, there's the ability to start recharging water back into the aquifer as well. So one of the other mitigation techniques is, where are potential areas for groundwater recharge? And how can we bring water in those areas? In areas like wine country, right? Like Napa, water reuse is a huge opportunity to bring water into the vineyards. And you're already seeing a lot of that work being done, but there's plenty of opportunity for water reuse from the municipal side into the agricultural sector, and finding the funding mechanisms to be able to do that. Because most of our customers are actually banks, we're looking at financial risk mitigation tools. So we're working with insurance companies to actually build water risk policies. So in some cases, that'd be like a parametric policy of, if a certain amount of water is not delivered from a water district or from the bureau, then the insurance policy can pay out. The other side of the funds would be, if certain loans do go into default, we can offset the profitability of those loans essentially from the interest rates with an insurance policy as well. And then directly, we're working with banks to actually build financial tools to help incentivize farmers. And it's not that farmers don't want to change their behaviors, they really do. They're wonderful stewards of land, but it's hard, it's expensive to like make the move from current agricultural practices to regenerative ag or organic ag. There's a 3 to 4 year window where profitability gets totally shot. There's huge capital expenses up front, and there's no way to fund that. So we're actually working with some financial companies to build financial products that funds those types of transitions with dynamic interest rates. So as things change on the ground, you're actually able to fund the changes over time so that the farmers can get to a sustainable state. So those are the kinds of things that we're thinking about and building with our farm banking customers right now, which is super exciting because it's a very different way to think about water risk and solve the problems of water risk. And it's one of the reasons we decided to really start with the financial sector. In our opinion, they're a linchpin to making all of the changes that we need to have made across the water sector, because they fund those changes over time. So that's really why we started right there, and why we started in ag, because ag is obviously one of the biggest consumers of water when we think about how and where water is being used.
What's your experience with the State Water Resources Control Board? I mean, water law in the Western United States is unbelievable. Just because it's not really good economics. It's basically built on use it or lose it and riparian rights and all of that. What's been the reception for what you've been trying to do with the regulatory agencies we have on water, like the State Water Resource Control Board?
Yeah, like we've had really interesting responses. We are a data company. We're a software company. We're agnostic on policy. Our goal, though, is to leverage data, better data, clean data, to help inform policy, though, because right now a lot of policy decisions really do get made in vacuums, right? It's not always taking into account all of the data that's available. It's taking into account the data that's maybe available to a certain group at a certain period of time. So our approach really is, let's aggregate the data into one big bucket, if you will, and start making better decisions based on what's really going on the ground. Forget north versus south, and environmentalists versus farmers, and east versus west in the Central Valley. Like, in order to really change policy, we have to make macro level decisions and understand the data at a macro level. Overall, like, there's a huge desire to have better and more transparent data across the board. One of the things that we're really able to do is, because we're working with banking data, which is highly secure, as you can imagine, and we're working with personal data from the farmers, we're able to act as like a third neutral party to aggregate data and information so that farmers' data stays protected, bank data stays protected, but we can make decisions using that data without exposing the data necessarily to the decision makers, where historically there's been conflict.
And I got to ask, on the name of the company, Water Bear, did that have some relationship to starting out trying to broker water? You had bear and bull markets, but what's Water Bear mean?
Yeah, no, it really had to do with a trip that a college buddy and I had way back in the day, some 25 years ago, into Estes Park. And we were right in the midst of some baby cubs and the mama bear in the middle of the night with our tent. And it was just like a really interesting, horrible, scary, fun experience. Because when you're 20 something years old, that stuff, you get terrified, but you have fun with it too. So yeah, the name really came from just sitting down and having a couple beers and trying to figure out what the heck I was going to name this company. And it was a placeholder, but it stuck because there's so many nuances to it as well.
That's great.
Interesting. Yeah, that's a great story. So Tony, if the horizons in water reuse, ultimately, when people understand how much money you're putting into treating the water, and then, why do you just throw it into the mix with all the other freshwater sources? And are we going to see a trend towards separate gray water systems, separate reuse water systems as a way to deal with the diminishing supply of water in the West?
Well, I think you're going to see decentralized sewage or waste treatment. That's one trend. The other trend is resource reuse. In other words, it may be shit to you, but it's bread and butter to somebody else. I mean, that is a pool of high nutrient water that's going down there, and why can't we just get the nutrients out? And there was just some work done just a while back where a lot of that sludge is taken out, put on fields. Some of that's basically bagged up and sent to the Home Depot and used for fertilizer and stuff, and people put it out on their lawns. And one of the emerging contaminants, the PFAS, is in the sludge as well as the liquid. So people are just taking it and circling it around. But I think, you're going to, especially here in California, we got to rethink, how we move water around and reuse it. I mean, why don't we cap the aqueduct and get, reduce some of the evaporation? Why are some of the agencies in the Central Valley just dumping water and not reusing it? I mean, we came into a rendering company. Well, 50% of the product coming into the front door is water. So, they are a net producer of water, which sounds kind of weird. But so, yeah, I just think we're going to have to look at using water very differently. And the way to do that is you have to value it. And the urban ag split, you got to also split some of it with nature. So it's a three-way split there. And generally nature ends up coming up with the short stick, so they don't vote too much, whereas the other two groups can vote. So I think we're going to see a distributed system, and possibly even brownouts.
There's a question in the chat that went to me that's for Tony that I'm going to go ahead and ask here. How in California, how many municipalities reuse their wastewater, or what's the kind of makeup of their wastewater? And can all cities and towns financially afford to reuse their wastewater, or is there a financial barrier there, or how would they overcome that?
Yeah, I mean, there are examples, especially in Southern California, of reusing water, and not just dumping it into the ocean. The trend is going in that direction. As to the question is municipalities, I think, the state has this thing called revolving fund where you basically get a loan and then it gets repaid. But I think, now we're a little flush. So maybe there's a way to, utilize some of that to get some of these infrastructure opportunities to, move forward.
Okay. Gary was having some quick issues there. Lynn Goldsmith notes that LA is also reusing sludge.
Yeah.
So Bill Carpenter, if you're still on there, obviously we're talking about subject near and dear to your heart, but relative to septic tanks and disposal. Do you want to give us a minute on EnviroCycle? All right, he put some information up on the chat. So his whole thing is in the remote systems where people are on septic tanks, there's a whole lot better way of dealing with that water too and bringing its quality up. It's basically aerating the septic tank. So we'll move on from there. Are there other questions out there in the audience? Mark Anderson, did you get all your questions answered? Okay, so he's okay. Let's see what else here is in.
Yeah, to give you a little bit of update on that, Gary.
Oh, here we go.
Yeah, I'm back in action here. In EnviroCycle, we determined that decentralization of the wastewater stream is one of the most important parts. Because of the cost of moving water, we're not only able to treat the wastewater at the home site, we're also able to discharge it into the aquifer. So we're recharging the aquifer. So we're saving a ton of money that way. So there are many environmental advantages to doing decentralized, as the previous folks have mentioned.
Right, and I'm glad to hear that you've got some other creativity there on what we do with the disposed of water and get it back in the system. So we have sort of a one-way system now, and we're not reusing a very large quantity of what we're doing.
Yeah, a lot of the stuff that we're doing now is in Napa County, where there are trace amounts of nutrients, phosphorus, nitrogen, that we're able to actually put into the crops that they're harvesting in Napa. And so even though it's small flow, it's 800 gallons per day, per site, we're still looking at, if you scale that out, we're looking at a pretty sizable savings as far as the treatment of wastewater and also reclamation of fresh water.
Right. Yeah, a huge area for innovation. Because it's mostly public systems, I just think that innovation is way behind on what's going on. So it's been great to hear from all three of you on a lot of the creative ideas you had, and then you're pushing things forward, getting people to think in different ways about what we do with water. But boy, it looks like drought is going to be a constant in our future. And I'll take advantage of Chris being up at Lake Tahoe. So I look to the east and I see big clouds over the mountains. You get any rain today?
It did. It actually did rain. It rains today. It cooled off quite a bit, and it was raining, and it was wonderful.
Well, get out there and get more of that. It may not contribute much to surface water runoff, but it'll take the fire danger down.
I think that water flows towards Reno.
Depends on where you are. Depends on where you are.
There's one dark side of the drought. We all know how to fix the drought if you're a water company, and that's just lower the pressure. The problem that we're seeing, we saw it in the headline in CNN yesterday about how Sacramento's water now tastes like mud. But when you lower the pressure, one of the problems is that will start, instead of water coming out of your pipe,
it goes in,
start sucking it in. And so if you've got aquifers, if you've got contaminated water, that's going to come in, and we can start seeing boil water notifications. So it's something that we've just got to look at. We've got to take a different approach as we have this. I mean, the last time we went through this in 2016, it looks like it's going to be here to stay. And I think all of the solutions are just, it's a great timing. And I just want to say, great to be with you guys, and great to finally meet some of you.
Yeah, well, it's good to see you again, Chuck. We're glad to see you're still here. You're back in the country and still playing the saxophone.
Yes, I am.
All right. Well, we're going to wrap up here. Thanks again to all of our speakers and for everybody who's participated. We have these kinds of discussion sessions once a month. We'll take our usual summer break and probably not have another one until September, but they've been very good this year. And I think, we're just trying to make sure everybody's on the cutting edge of what's going on and knowing the people in the network that we have in the greater Sacramento area here. So, Carlos, anything else you want to comment on about the Urban Water Master Plan before we sign off?
I think a lot of good stuff was covered here. Obviously, a little bit of a different jurisdiction than myself. But in terms of what the city is doing, it may be relevant to some of those that are on the audience in terms of asking citizens to conserve water. We're taking steps. We're considering a number of measures ourselves. I think it was a really great panel and just enjoyed being a part of it. So thank you.
All right. Well, get out there and inspect those pipes. Want to make sure we're not losing 20% of our water. So Thomas, let me turn it back to you. And again, thanks everybody for joining.
All right. First, I want to thank all of our panelists, guests, and everyone today. Big round of applause. I really appreciate it, putting this together for us. Thank you, Chris, Chuck, and Anthony for joining us. I also want to thank our overall program sponsors, Momentum, Greenberg Traurig, PIM Motion, Reverent, Hacker Lab, and Moss Adams, and our community of partners. And I want to thank all of you for attending. Check out our next upcoming CleanStart perspectives on the 29th, 6th, 12th, and 13th. And our next CleanTech meetup in September, we're planning to do it in person. So come in, let's get back to some semblance of normal and see people in person if everything's safe enough. So thank you for attending.
All right. Thank you all.